Hi, my name is Isra binti Masya Izam and my matrix number is AE240892. So, I will explain about the introduction. In digital systems, sequential logic plays a crucial role in designing circuits that store and process data based on time or sequence. The main goal of this project is to develop a binary counter using registers and finite state machine FSM, which are crucial components of digital electronics. So the component that we use are counter, which divided by 2. The first counters is asynchronous counters and the second counters is synchronous counters. And then we have finite state machine FSM, and also we have register.
So here is the table. So we have the present state, next state, FFC, FFB and FFA. So we have 3Q, which is QA, QB and QC. So first we start with the 1. So 001, the next state is 010. So the present state is still the 010 and the next state is 011, which is the binary number, decimal number is 3. So next we have 011 and the next state is 100. Present state 100, the next state is 101 and the present state 101 and the next state is 110. Next 110 and then 111 and 111 and 000. So our last is 000 and next state back to the 001. And the flip-flop is we use the table. The excitation table is QN, A plus 1, J and K. So when the 00, so the J will 0, K will X, and 0, 1, X, 10, X1, 11 and X0. So I use that table for our JA, KA, JB, KB, JC and JC and KC. Assalamualaikum warahmatullahi wabarakatuh. My name is Najwa binti Muhammad Zaini. Now matric A824059. So here is the ticket cat that I create. The sequence that I use is 1, 2, 3, 4, 5, 6, 7 and 0 and looping.
Assalamualaikum, my name is Kisina binti Muhammad Nasir. Today I will present to you about my task B. Task B is the parallel in shift register using JK flip-flop. Based on my circuit, I have 4 input, 4 output, 4 JK flip-flop, 1 clock pulse and 1 clear. This is based on my circuit that I made. Based on my circuit, I will do the simulation based on the table. So I will do at least 8 example. So for the example 1 is all the input is 1 and the clear is also 1. So we got the output is all output is 0, and if we change the clear to 0, we also got the output 0. And let's say we change the clear to 1 and B to 0, and we got the output B is 1. And we change again the B input to 1, and this time we will use the clock pulse, and yeah, the output is C equal to 1. And if we use the clock pulse once again, the output is D. If we use again, the output is 1, again B, and again is C. This is the result that I record based on my simulation on that circuit based on the table given.
Hello, my name is Siti Nurzunaira and my metric number is 241062. And I'll discuss a discussion. For the first task, our group designed a multi finite state machine, which is FSM, using 3 ZK flip-flops. We started by creating our own state transition diagram based on a unique counting sequence that shown in this project report. Then we prepared the excitation table and K-maps to get the correct logic expression for the ZK inputs. Using this, we built the circuit in Tinkercad by connecting IC 7473 flip-flops with the necessary logic gates. During the simulation, we observed the output to ensure the counting sequence worked correctly with each clock pulse. This does help us better understand how FSM works, especially in designing and controlling digital system using sequential logic. And the second task, which is task B, parallel in-shift registers using 7476 ZK flip-flops simulation using Logisim. For the second task, required us to build a 4-bit parallel in-load recirculating shift register using 7476 ZK flip-flops in Logisim. First, we clear all the flip-flops and then turn off the clear inputs before loading data in parallel. When we applied clock pulse, we could see how the data shifted through the flip-flop one by one and circular manner. This simulation helped us to understand how shift registers store and move data, and how important timing is in digital circuits. We also recorded our result in the table in the report, whether the outputs match the expected behavior or not. The conclusion, we can conclude that this project required us to collaboratively design and simulate 2 key digital systems, which is a multi-type finite machine. The first task using ZK flip-flops in Tinkercad, and the second task is a 4-bit parallel in-shift register using 7476 ZK flip-flops in Logisim. By engaging this schematic design, circuit construction, simulation and documentation, we had to develop practical skills in digital logic design, teamwork and technical communication. We were also required to simulate the data shifting process, observe register outputs after enabling, disabling clear input and record results systematically. Through this task, it also enhanced our skills in digital circuit analysis, simulation software such as Tinkercad and Logisim, also teamworks, as its members had to collaborate in legit roles and contribute effectively to complete this project. Thank you.